introduction to sampling. Let's say that you have your population here, and you take all of the data from the population and you analyze it. This is called a census. Now, if the population is small, then doing a census could be quite easy, quite a practical way of doing things. If the population is really large, for example, the population of all the people in the UK, which is done once every 10 years, we have that census. That's very time consuming, it's very expensive, costing around £500 million, and by the time the data is collected and analysed, the population has already changed, so the results may not be as useful. As an alternative, and a more sensible approach, we take a sample. And this is to obtain information about the population. Typically it's quicker, it's cheaper. What we're looking for is an unbiased sample, so something that's fair, something that represents the population. The ideal sample would have the same properties of the population. It's just a smaller version of the population. These are the 5 different types of sampling methods that you need to know. Random sampling, there's 2 versions. Unrestricted, where you could have the same member of the population chosen twice or 3 times and so on, because every time something's chosen, it's put back into the population, so it has another chance of being chosen again. A simple random sample, this is the one that we normally use for surveys. It's without replacement, so any member of the population chosen is not replaced back into the population, so you can't select somebody twice. Stratified and quota sampling methods are very similar. You take the population, you divide it into groups or layers, and then you're selecting using proportionality from each of those particular groups. In stratified, you end up selecting using a random sampling method, and for quota you select by convenience. And then we have cluster sampling, where your population is divided up into clusters. Again, they're like groups, and you randomly select some clusters, and then you select from within them. The way you select from within the clusters is using random sampling once again. And then lastly, we have systematic sampling, where you might be selecting, for example, every 10th member of the population in a systematic way, using a pattern. Now, some of these sampling methods will give everyone an equal chance of being selected, others won't. They all have their advantages and disadvantages. The definition for a random sample is very important. Every member of the population has an equal chance of selection. That's the first part. That's the most commonly remembered part of the definition. The second part states that you can select any subgroup of the population. Another way of saying the same thing is you can select, your selections should be independent of each other. For example, if you have a hall which has 200 people and you're selecting a sample of 10 people, you should be able to select any combination of 10 people. There should be no restrictions as to who can be in your sample. Methods used to randomly select include random number tables. This is the last page in the AQA formula book, and what you see here are just random numbers. And the way to use these numbers is just randomly start somewhere, and then depending on, for example, that one there, we may be looking at 3-digit random numbers, so 119, and the next one 512, next one 539, and that sort of thing. When you reach the bottom of the table, just randomly start somewhere else and continue. The wrong way to use these is to think, well, I'll just start in the top left-hand corner or in the top right-hand corner. That would be wrong. If everybody started in the top left-hand corner, we would all end up with the same sample. And this is about random sampling. We could use the random number generator in the calculator. A good way to use this is to do 1000 times this function. Shift, random number generator, equals The reason to multiply by 1,000 is so that we don't get decimal numbers. And as you can see, we're generating random numbers here, 3 digits. If it's 2, you can imagine there's a 0 here, so that's 3-digit number there, 052 641 829. And then we can use these numbers to randomly select. We could use a traditional method here. If the population size is small, we could take all the names, put them in a bag, and then select names out of the bag that way. Let's have a look at this context here. Using this context, we'll have a look at all of the sampling methods just described. This particular supermarket has 300 shops throughout the UK. There's 4,000 workers. These are the job types and the number of people that belong to each of these job types. Inside each store, there's about 12 to 100 employees. So how would we select a simple random sample of 200 workers from the 4,000 workers who work for this supermarket? Well, the first step involves random numbers. Okay, we give each worker a number. The first worker takes the number 0000, and the last one will take the number 3999. So this step is numbering the population. Step 2, select 200 4-digit, because these are 4 digits here, random numbers. Ignore repeats, because we're looking for a simple random sample. We don't want the same person twice. And ignore numbers greater than 3,999, because no one has a number greater than that. And then step 3, select the corresponding employee. The advantage here is that it's unbiased. The disadvantage, these 200 workers are going to face interviews from the HR department from this company, but the interviews are face-to-face. So the HR department has to travel out across the UK to all of these different locations to interview these 200 workers. And that can be a lot of travelling. That could be expensive and time-consuming. Stratified sampling. Here we're trying to select 200 workers based on job type. The job types are these: senior managers, store managers, head office, general workers. What you need is this formula, and you need to memorize this. It's not given to you in the formula book. Layer divided by population times sample size. So, for example, we have 100 senior managers. So in that particular layer, the layer size is 100. The population size, well, there's 4,000 altogether, and the sample size is 200. So when you put those numbers into the formula, you get 5. What this is stating is that we need 5 senior managers to be represented in the sample. Applying the same calculation to all of the other layers, so 300 store managers, so what you would be doing there is this: 300 store managers divided by the population size times the sample size. There, 15. Okay, so remember, it's the number in the layer divided by the population size times the sample size. And they all add up to 200, which is what they should do. Now we need to look at how do you select these 5 senior managers from those 100. Whatever method we're going to apply to the senior managers, we will use the same method for selecting these 15 store managers from those 300, these 4 head office staff from the 80, and so on. Okay, so for the senior managers, step 1, number them. 0000 to 0099, so there are 100 senior managers in there. Step 2, select 5 4-digit random numbers. Ignore repeats and anything that's more than 0099. Step 3, select the corresponding names of these senior managers. Now you don't want to describe this method over and over again for all of the other job types, for all of the other layers in the population. So this is what you would state next. Use a similar method for the others. So what's the major advantage of using a stratified sample? A stratified sample ensures that all of the layers are fairly represented. So no one particular layer in the population is over-represented or under-represented. So it's avoiding bias. This is a very desirable quality in most surveys, so that every part of the population has a fair representation in the sample. Now, one of the reasons you would divide up your population like this into various layers is because for some reason you think the views held by each of these layers would be different. So you think that the senior managers would have different views to the general workers. If you thought that the views of all of these workers were similar and there isn't a major difference between the various job types, there would be no point in doing this at all. You're better off just doing a random sample rather than doing this stratified sample. Another advantage is that all members have an equal chance of being selected. A disadvantage, not truly random. Okay, this slide here explains the advantages and disadvantages of stratified samples. A quota sample of 200 workers, again based on job type, is very similar to stratified sampling. In fact, a quota sample is referred to as a stratified sampling with convenience. So once you've got to this stage, so up to here the working out is exactly the same as a stratified sampling. Now we look at how do we select these 5 senior managers from these 100. Okay, so there's 100 senior managers. How do you select those 5? So we know that we need 5 people from this particular layer. What you do is you select by convenience. And by this we mean you select any 5 that you want. So it's somebody's job to go and select those 5 senior managers. The advantage here being you can avoid people who are off sick, on holidays, in meetings, too busy, don't want to take part, that kind of thing. The disadvantage is that this system is a little bit open to abuse. So the person doing the selections could be biased and is looking for specific views from certain managers and knows who to target. So the disadvantage is you have bias. Okay, have a look at this slide here, which summarizes the advantages and disadvantages of quota samples. Cluster sampling. Our population consists of 4,000 employees who are distributed amongst the individual stores. There are 300 individual stores, so we have 300 clusters, all in different geographical locations. And this is quite typical of cluster sampling, where you have large groups of your population grouped together in different geographical locations, called clusters. We're going to randomly select the required number of clusters. In this case, we're going for 20 stores. And then we're going to randomly select from within each cluster. So from these 20 stores that are selected randomly, we randomly select 10 employees from each. So 20 times 10 gives us a sample size of 200. So the first step, we have 300 stores, or 300 clusters. We number them 000 to 299, and then we select 3-digit random numbers. Ignore repeats and ignore numbers greater than 299. we're looking to select 20 stores or 20 clusters. So select 20 of these 3-digit random numbers, and then select corresponding store or cluster. So now you have the names of 20 stores. So instead of potentially traveling to hundreds of different stores, we're only going to travel to 20 of them. So you can see a main advantage right here. We have reduced the amount of traveling required, because in this whole process we're going to have face-to-face interviews between HR and the employees who are working in these stores, which requires traveling to the store. Now you only have to travel to 20 of them instead of potentially hundreds of them. Okay, that's the first step. Second step, now that you know which stores to target, how do you get the employees from within the store? Well, you use a random process. So use random sampling again to select, and this is the key part here, the same number of employees, and we're going to use 10. Yeah, the same number of employees from each store. Because there's 20 stores, if we select 10 from each, 20 times 10 is 200. That's the sample size that we're looking for. Now there are between 12 and 100 employees per store. So if you've picked one of the smaller ones, you're picking 10 employees out of 12. That gives everybody a high chance of being selected. If you've picked one of the larger stores, you're selecting 10 employees out of 100. So everybody has a smaller chance of being selected. So as you can see, everybody does not have an equal chance of being selected with cluster sample. This is a summary of all the advantages and disadvantages of cluster sampling. Biased views by location. Yeah, that's one of the key disadvantages. You may find that your 20 stores selected are all in the southeast, and because you're randomly selecting the stores, that could happen. It's a bit unlikely, but it could happen, and if it does, your views will be biased. The views between the southeast and the north may be different, and what you're looking for is a mixture of views across the UK. And moving on to the last sampling method, systematic sampling. This is where you select every nth worker. Now there's a formula that gives you the value of n. N is equal to the population size divided by the sample size. And in our case here, our population size is 4,000 divided by 200, which gives us 20. That value 20 will be used for two things. It tells you where to start in the population, so who's your first person that you're going to select, and we know that we're going to select every 20th person thereafter. Okay, so n is equal to 20. So again, you need your population numbered from 0000 to 3999. So you've got a list of names, you've given them all numbers. Now you're going to select the first person, and the first person is randomly selected between 0000 to 0019. There are 20 people inside this range here. So you randomly select the first person. So randomly select first person. So as an example, let's say if we have randomly selected person number 8, yeah, the person who's got the number 8. So your first person is this, 0008. So the next one, we'll add 20 to this. It's 0, 0, 2, 8. The next one after that, add 20 again. And how do you know you're going to add 20? Well, it's all based on this, n equals 20. So 0, 0, 4, 8, etc. Okay, the advantage, all employees have an equal chance of selection, so it's a fair sample, it's unbiased. Disadvantage, it's not a random sample, because you can't select all subgroups. Your selections are not independent of each other. As soon as you know one number in the population that you're going to select, you know the next one will be 20 places away. So, for example, you can't select these two people together. There's no way. If you've selected 9, then you add 20, the next one will be 29, so you can't have those two together. It's good to avoid alphabetical lists, because you may find that certain surnames of perhaps ethnic minorities are grouped together, and because you're taking jumps of 20 through the population, you may miss them altogether. And you may run into problems in situations where you have patterns within the population that can cause bias. An example of that could be a factory that's producing components for machines, and every 20th component for some reason is faulty. And if you're selecting every 20th component using systematic sampling, you may miss all of the bad components, or you may only select all of the bad components. So if there's any underlying patterns within the population, it can cause problems.